Enzymes. They're tiny, they're invisible, and you have billions of them working inside of you. Ever since the moment you were born, they were in you. But what are they? Why do you need them? And how do these microscopic machines literally keep you alive every second? Today, I'm going to be breaking down enzymes in what I feel like is the simplest way possible. No complicated biology degree needed or anything like that. Let's just get right into it. Before I get too into this video, I just want to emphasize I am not degreed in this. I am not any certified to do this besides the research that I did. I just want to explore all these random topics that I think about that you might think about too. If I'm wrong, please write a comment. I have no problem making a revision. I have no problem changing things. This is just my personal exploration, and I do want to share it with you. Have a great one. An enzyme is a protein that speeds up chemical reactions in your body. Think of it like a helper, maybe a worker, or even a little biological machine, as I referenced earlier. Without enzymes, everything in your body would happen way too slowly. Digestion, building muscles, healing wounds, copying DNA, all of these would practically stop. So the easiest definition is enzymes make reactions happen faster so life can happen at all. Let's dive a little bit more into why your body needs them. I'm going to try to make this as relatable as possible. Every second, your body is doing millions of tiny chemical reactions, breaking food down, building new cells, producing energy. Enzymes make all of those reactions actually possible at normal body temperatures. Some examples of what enzymes help you do: digesting food, keeping your metabolism running, building and repairing muscle, detoxing chemicals in your liver, as we know, some of you might be drinking, copy DNA when cells divide. If enzymes disappeared, you basically freeze in place. As I said before, your life literally depends on them. Now, I'd like to break down how enzymes actually do their jobs. Every enzyme works on something. That something is called the substrate, as you can see from the diagram. A substrate is a molecule that an enzyme is designed to act on. If the enzyme breaks something apart, the substrate is the molecule that's being broken. If the enzyme puts something together, the substrate is the starting pieces. If it transforms something, the substrate is whatever's being changed. Think of it like ingredients in a kitchen. If the enzyme is the chef, the substrate is the food being chopped, mixed, or cooked. Every enzyme has a special pocket or groove called the active site. Inside of this pocket, a process happens. The first step of the process is the substrate fits into the enzyme. As you can see, it typically looks like a puzzle piece going in. The enzyme then holds it still and makes the reaction easier. The enzyme then decides whether it should break it apart or rearrange it. The new pieces, called products, leave the enzyme, and then the enzyme goes back to its original shape and can repeat this. The enzyme itself is not changed or used up. It's like a tool that can be reused over and over again. Earlier, I brought up that enzymes speed things up. I want to emphasize a little bit more how they do that. The first thing they do is they pull the substrate into the perfect position. If they didn't do this, some things would take years instead of seconds to break down. They reduce the energy needed for the reaction, and they also stabilize the molecules as they react. That's why enzymes are often described as biological catalysts. To summarize what a substrate is, it's simply the thing that the enzyme works on. There are two ways scientists explain how enzymes and substrates fit together, and in this video, I'm only going to give you the general big idea. The first is the lock and key method. Enzymes have a special pocket called the active site, which we went over earlier, and only the right substrates fit into it, like a key fitting into a lock. If the shape matches, a reaction happens. That's why enzymes are extremely specific. One enzyme usually works with one target. However, there is some leeway in that method. A more accurate version is what is called the induced fit idea method. Instead of being a perfect fit from the start, the enzyme can slightly adjust its shape around the substrate, kind of like how your hands adjust when you grab an object. This flexibility helps the reaction happen a little bit more easily. Whether you picture it as a perfect lock or a flexible hug, the main idea is the same. The enzyme and the substrate must fit each other, and that fit is what allows the chemical reaction to happen. Now, let's look at some real life enzymes you've actually used probably today, even if you didn't realize it. The first one we're going to go over is lactase, the milk enzyme. Lactase is the enzyme that breaks down lactose, the sugar in milk. If you're lactose intolerant, it means your body doesn't make enough lactase. This is found in your small intestine. It breaks down lactose, which turns to glucose, plus galactose. Without it, you get bloating, gas, and stomach discomfort. So lactase's substrate is lactose. The next one we're going to go over is amylase, the carb breaker. Amylase is found in your saliva and your pancreas. It starts breaking down bread and starch the moment you start chewing. It's one of the first digestive enzymes you ever will learn about if you're going to school for it. Turns starch into simple sugars. That's why crackers get slightly sweet if you hold it on your tongue. Its substrate is starch. Next up is pepsin, the protein cutter. Pepsin lives in your stomach acid and breaks down big proteins into smaller pieces that your body can absorb. It works best in very acidic conditions. It helps digest meats, eggs, and if you're drinking protein shakes. It's one of the strongest enzymes in your digestive system. Its substrate is proteins. DNA polymerase, the DNA builder. This one is awesome. DNA polymerase is the enzyme that copies your DNA. Every time your cells divide, the enzyme builds an entirely new strand of DNA. It's incredibly accurate, copies billions of pairs, and fixes mistakes as it goes. Its substrate is nucleotides, the building blocks of DNA. To summarize different enzymes, I just want to emphasize that your body has 5,000 different enzymes, each one with a very specific job. Some break things apart, some build things, and some, like DNA polymerase, literally keep you alive by copying your genetic code. Enzymes might be microscopic, but they are some of the most important molecules in existence. Without them, digestion fails, cells stop working, energy stops flowing, life simply wouldn't work. If you want some more biology videos, hit subscribe, drop a comment, and let me know what topic you want me to break down next. Thanks for watching.